These are the fourth set of notes in Chapter 9, Punnett squares with dihybrid crosses. By the end of these notes, you'll be able to predict the genotypic and phenotypic ratios of an offspring from a dihybrid cross. We'll do the predicted ratios of various crosses later. Here's the definition. It's a cross between individuals where two characteristics are considered. This is the example from your book, and they use wrinkly seeds versus round seeds as one of their traits. The other trait is the color of the peas, either green or yellow. So how do we set up a dihybrid cross? First, we have the parents here. And the first thing to do is to look at what's dominant and what's recessive. So in this case, round seeds are dominant over wrinkled seeds. Yellow seeds are dominant over green seeds. This parent would be a round yellow pea. This one would be a round green pea. Now, we have to determine all the possible combinations of eggs and sperm. In other words, we're looking for the gametes that could possibly be formed during meiosis. So let me show you how to do that. Each parent can produce 4 different combinations of these letters, or 4 different possible gametes. We will determine the 4 possible gametes of this parent using the FOIL method that you have been learning in math class. So here it is, FOIL. Let's bring our parent down here. First, we're going to do the first of each letter. The first R and the first Y. Here they are, 2 capital letters. We're going to use the outer letters, R and Y. In this case, the Y is lowercase. Here they are. We'll use the inner letters, little r and big Y. And we'll use the last of each letter, R and Y, both lowercase. Please feel free to rewind if you need to see that again. Now we're going to go on and talk about this parent. And we're going to determine the possible gametes for this one. This one is a little bit easier because all the R's are the same and all the Y's are the same. But the FOIL method still works. We'll use the first of each, a capital letter R and a lowercase y. Outer, capital R, lowercase y. Inner, capital R, lowercase y. And last, capital R, lowercase y. So you see the FOIL method works, even though you could probably just look at that and tell me that each one will be the same. So let's go back and put those on our Punnett square. I've put this individual, our round yellow seed, on top, and our round green seed on this side. Just like in the monohybrid crosses, you'll bring each letter down and distribute it to each of the boxes. Instead of 2, there are 4 in each column and 4 in each row this time. So this R will distribute here and here. Let's take this R and move it down to the bottom box and fill in the other 3 as well. Lowercase r, move it down to the bottom box and fill in all of the others. Small r, move it down into the last box and fill in the other ones as well. Now at this point, I find it easiest to go ahead and do all of the R's first. If you're having trouble keeping track, you can always put a little line through the R's here to let you know you've already distributed them. So let's start on the left side and distribute these. The first one here, and then fill in the other 3. One more time, the first R, and fill in the other 3. Again, bring the R over and fill in the other 3. One last time, and fill them all in. Now I'm going to go back and distribute my Y's. It doesn't matter if you do this one first or this one, but just be consistent. I'm going to start at the top and bring this Y down and fill them in. Bring this Y down into each of the 4 boxes. This is a capital Y in each of the 4 boxes. And here's a lowercase y in each of the 4 boxes. Now that I've done these, I'm going to go back and distribute these. They happen to all be lowercase, so this y will be distributed into each of the 4 boxes. This y will be distributed into each of the 4 boxes. One more time, a lowercase y in each of the 4 boxes. And the last time, a lowercase y in each of the 4 boxes. So now you have your offspring. Not too complicated, huh? Let's go on and talk about how to determine the genotypic ratios. I already have them listed here, which you may not have them listed out on your practice problems. So what you do, just pick a box, write the genotype off to the side. So here's my first one, and here it is. And then count up all the other boxes with the same genotype. This has 2 capital R's. So we can immediately eliminate these because they have a capital and a lowercase r, so I know they're not the same. Move on to this one has a capital Y. This one does not, so I will eliminate it, just like I will eliminate the rest in this column because they have 2 lowercase y's, which leaves these 4 matching this genotype. So I have 4 that have this genotype, and then I have 12 that do not have this genotype. Here they are, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my ratio is 4 to 12. We're going to reduce that, divide both sides by 4, and you get a 1 to 3 ratio. Now, I would put a slash mark through these because you've already counted them, and let's go on to the next genotype we see, which is this one, 2 capital R's and 2 lowercase y's. Here it is. Count up how many have this genotype. I know I can eliminate these because I've already counted them for genotype. These all have lowercase r's in them, so they don't match. We're left with 4. 1, 2, 3, 4 that are this genotype, and once again 12 that are not. We reduce that and we have a 3 to 1 ratio. I hope you're seeing the pattern here. The next genotype we go to is heterozygous for both traits. So we pull that over here and count them up. Do you see the pattern? They tend to be in columns, and this will be true throughout. However, the genotypic ratios will not always be 1 to 3 for each trait. It really depends on the type of parents you're dealing with. So 1 to 3 for this one as well, and the same for this. There's 1, 2, 3, 4 of this particular genotype, and then there are 12 that are not. 4 to 12 is reduced to 1/3, 1 to 3. Now, thinking about the phenotypes is a little bit different because what are these peas going to look like? This is where some extra colored pencils or even just a different color pen may come in handy. And what I have done and what you can do is circle the yellow peas, which is dominant, so all of the capital Y's, circle them in yellow or highlight them with a yellow highlighter. You could go through and all of the homozygous recessive peas you could highlight in green, so you know what color these peas are just by looking at the chart. I have left the green peas black. The other thing you need to do is the other trait, round seeds versus wrinkled seeds. I chose to shade all of the boxes gray that had round seeds and leave the wrinkled seed boxes white. You'll notice that there are no offspring with the homozygous recessive wrinkled seeds. They all have a capital letter, so I have shaded all of the boxes gray. Now, how many of my peas are yellow and round, which means they have the yellow type and a shaded box? 1, 2, 3, 4, 5, 6, 7, 8. So 8 of them are yellow and round. How many are not yellow and round? 1, 2, 3, 4, 5, 6, 7, 8. That's an 8 to 8 ratio. Again, we're going to reduce it Divide both sides by 8, and it's a 1-to-1 ratio. 50% of my peas will be yellow and round. Let's count the green and round peas. Here they are, 1, 2, 3, 4, 5, 6, 7, 8. Once again, our ratio is 8-to-8. Reduce it to 1-to-1, and we have 50%. We know just by looking at the chart, because all the boxes are shaded, we will have no wrinkled peas, green or yellow. There are practice problems on my website.